Good evening, everyone. Today I am going to explain a basic electrical in which I am going to explain a DC circuit. A DC circuit. So first of all, I am interested in the definition of DC circuit. That means, what is a DC circuit? Any circuit that is sourced by DC, that means direct current. For example, I'm going to draw a circuit. This is the example of DC circuit where a battery is connected here and a resistance is connected here, and here a current is flowing through this wire through this resistor. Okay, then from the Ohm's law we can write VDC is equal to IDC into R. This is the example of DC circuit. Okay, here source is what? Any battery or DC source. That's why I am telling this DC circuit. Okay, thereafter I am going to explain the basic DC circuit element. The basic DC circuit element, that is resistor, second one is capacitor, and third one is inductor. Okay, so I'm interested to know what is a resistor. Resistor is an electrical element that resists to follow the electron. That means any electrical element that resists to flow of electron, that is called resistor. In the presence of the resistor in any circuit, there is a power loss. There is what? There is a power loss. For example, this is the again DC circuit, and a resistor is connected here, and from the Ohm's law we can write VDC is equal to I into R. From the view of or reference of this circuit, with the presence of resistor here, there is a power loss. That means loss of power. That will represent in a mathematical way like this: power loss is equal to I square R, and represented at watt. That means if someone asks to you, in the presence of the resistor, how much power will be lost, we can easily apply this formula. That means what? I square R, and we can normally calculate the power loss. For example, if here 10 volt is a supply and the value of resistance is given, again 10 ohm, then how much is the current flowing through circuit? Obviously 1 ampere. Okay, and what is the power loss in this circuit is, we can write 1 square, that is 1 ampere. And what is the value of the resistance? 10 ohm. And power loss will be 10 watt. Okay. So finally, in the presence of resistance, generally power loss occur. Thereafter we will deal the capacitor circuit, and for the resistor there is a particular resistance and it is normally denoted as ohm. Now for the capacitor circuit, let us take a look. I am going to rub for representing this, and again rubbing the headed for better representation. Okay. Got it. So this is the capacitor. And for the capacitor there is a capacitance and measured as farad. Okay. Now the question is, what is a capacitor? Capacitor is an electrical element that normally stored the energy in a static form. Okay. Then the question is, how much energy it will store? It will store energy half CV square. How much? For example, if any DC circuit, if we connect a capacitor, VDC, again current I, this is the capacitance, then if we are interested how much energy this capacitor will store and what is the capacitance of this capacitor, we can normally write E is equal to half C and VDC square. Again, if we take the numerical value, that means for example if 2 volt is here and value of the capacitor is let us example 4 farad. Okay, then if anyone asks to me what is the energy stored in this capacitor in a static form, we can write like this: half, what is the value of C? 4 farad. Okay, then 4, and what is the value of VDC? This is 2 square. Then it will cut, okay, 8 joule. Then here 8 joule is energy stored in this capacitor. Okay, so capacitor finally store the energy in a static form. Okay, my next topic is inductor. I'm going to rub it for explanation of inductor circuit. This is the inductor. Okay, and for inductor we normally see the inductance and it is measured as Henry. Okay, again take a DC circuit. If inductor is connected here, this is the VDC and current flowing through this I. Then for the inductance, first of all we want to know what is the inductor. Inductor is an electrical element that stores the electrical energy in a magnetic form. But what is the capacitor? Capacitor stored the electrical energy in a static form. Both are the energy storage device, but capacitor stored the energy in a static form, but inductor stored the energy in a magnetic form. How much energy it will store? It will store energy half L I square. Again, take a numerical example. Let us take this one is 2 volt, and for the current we take 2 Henry, and inductance here is given 2 ampere. Current is always represented as ampere and inductance is represented as Henry. Okay, then how much energy it will store? Half. What is the value of L? 10. And what is the value of I? 2. Okay, 2 cancel. Then 10 joule. From this circuit point of view, energy stored in this inductor is how much? 10 joule. So it is clear. Now next topic is Kirchhoff law. This is a very important law from the point of electrical engineering. So in the Kirchhoff law there are 2 types of law: Kirchhoff current law and Kirchhoff voltage law. So Kirchhoff current law is what, and Kirchhoff voltage law is what? I am going to explain Kirchhoff law. 2 types of law, first and second. First is Kirchhoff current law, and second one is Kirchhoff voltage law. Okay, in short we represent KCL and this one is KVL. First of all, I am explaining KCL. According to statement, the sum of total incoming current is equal to the sum of total outgoing current at any node. Statement is what? The sum of total incoming current at a node is equal to the sum of total outgoing current that node. So we take an example: I1, I2, I3 and I4. Here is what? I5, I6 and I7, and this one is what? A, and A is a type of node. So node is a point where 2 or more than 2 electrical element connected. So at this node, what are the incoming currents? We are looking the figure and observing I1, I2, I3 and I4 are incoming currents, but I5, I6, I7 are outgoing current. So according to statement of KCL, we can write at node A, I1 plus I2 plus I3 plus I4 is equal to what? These are total incoming currents, and this is the total I5 plus I6 plus I7 are total outgoing current. These are what? Incoming current, and these are what? Outgoing current. Okay. Thereafter, an important statement from the Kirchhoff voltage law, that is in short we generally called KVL. Okay, so now I will explain KVL. For this, according to KVL, statement is what total voltages KVL in short, and it is Kirchhoff voltage law. According to KVL, total voltages in a closed loop circuit, or the sum of total voltages in a closed loop circuit is equal to 0. Let us take an example. Okay, this is V1, this is R1, this is R2, and this one is V2. According to KVL, all voltages sum in this loop, obviously this is a closed loop. Okay, sum of all voltages in a closed loop is equal to 0. I am going to write down the sum of voltages first of all, thereafter we will equate it to 0. Then V1, obviously plus sign, here is a current I1. You can see here these are the resistor. In the resistor or at the resistor there is a voltage drop always, so we normally represent in minus sign, minus I1 R1 and minus I1 R2. Both are the different resistor. For that different voltage drop I am showing here, and at the circuit minus V2 is equal to 0. Okay, so these are the voltage sum. I am equating it to 0 according to the Kirchhoff voltage law. If we take an example to a numerical value, then let us consider here is a 2 volt, here is a 4 volt, and current flowing through it 1 ampere. This is just a numerical value. I am taking the example, and this is a 10 ohm, this is also a 10 ohm. Okay, so how can we write this? Plus 2 minus 1 into 10, 1 into 10 minus again 1 into 10, 1 into 10 minus 4. It will comes out to be 0 always. It will comes out to be 0 always. For better representation, you can write here, that means equal calculations, we can write it 14 volt. Okay, or 24 volt, then it will satisfy the overall equation. But the basic concept is this: the sum of total voltages is equal to always 0. Okay, thank you.